Hi, I am Engineer Ahmed. Again, today we are discussing pneumatic actuators. So, as we discussed in earlier types of actuators, pneumatics means air pressure, operating with air pressure from the compressor. So, globe valves. There is a globe-like structure which is going up and down, sliding stem type globe valve. So, this is a globe valve. So, on that there is a coupling. So, to this coupling, so the stem of the actuator and the valve actuator are coupled here. This is called the coupling. So, this is your main actuator. So, there are two types of actuators, direct acting and reverse acting. So, what is the difference? So, we will see now. So, direct acting means air to close. So, if you give air signal or pneumatic signal, it will close. That means when air is not there, it is a open condition, open position. So, reverse acting is a operating air to open. If you give air or signal to open, air to open or signal to open. That means when there is no signal, it is in closed position. So, from close to open. So, this is from open to close. So, that is a difference, main difference. Operation is the same. So, that's why I have not shown the other parts. So, depending on your process requirements, so this type of actuator will be selected. What is a safe position for the control valve when a signal fails? So, there is a chance of signal fail, maybe in the controller or in some system, compressor systems, there is a suddenly signal fail. So, what is a safe position? That is a process requirement. So, if a safe position of the valve is open condition, so you have to use the direct acting type, that is air to close. When air fail, it will be open. Similarly, reverse acting. Reverse acting means air to open. That means air fail, it will be closed. That means what is a safe position for in this application? Closed position. For example, this gas applications. So you cannot leave the gas outside. So you have to, in emergency condition, when signal fails, the valve should be in closed position. So in such condition, we will use reverse acting or air to open. So in both these cases, the construction details we will see. So here the main part is a diaphragm. Diaphragm is a key element in this diaphragm, in these actuators. This is a diaphragm. This diaphragm is made up of some polymer, nitrile or some other material. So it is a elastic type. So elastic means it will be going up and down, and it is housed in a metallic housing. That is this is a housing completely sealed, like a flange. So it is a completely sealed. So this is a housing that is made up of completely metal, and then there is a spring is there to restore the signal. So there is a stem also. Stem is connected to the diaphragm, so which will be going up and down, coupled with the valve stem through the coupling. So what happens is pneumatic signal comes from the positioner and enters into the top of this housing, and this air pressure is applied on the surface of this diaphragm. So when air pressure is applied on the diaphragm, it develops the force and pushes the piston stem or piston down against the spring force. We are continuing with pneumatic actuators. So when the signal is applied on the diaphragm, that is air pressure is applied on the diaphragm, it will actuate, it develops the force and presses. There is a movement of the diaphragm downwards. So because of that force, this plug in the valve goes down and it closes. So similarly, in the reverse acting type, operation is same, only the signal is giving from the bottom of the actuator. So here this signal, air pressure pushes the diaphragm up against the spring. So here spring stretches, and as the signal is reduced or comes down, this spring will again comes back to its original position quickly. So spring is very much required for a restoring force, to restore the original position. So we need a spring also, very important. So other than that, we will have a other components like electro-pneumatic converter. So electro-pneumatic converter, as the name suggests, it receives the standard electronic signal, that is 4 to 20 milliamperes, as an analog output from a controller or a DCS or a PLC, and it converts into pneumatic signal. Pneumatic means 3 to 15 psi. This 3 to 15 psi goes to the positioner. So why positioner is required? Positioner is also a pneumatic instrument. So it will amplify the pneumatic signal 3 to 15 received from the electro-pneumatic instrument, and it develops, amplifies the pneumatic signal, and it gives the more pressure to the diaphragm. Why it is required? Because we have a large process pressure inside the control pipeline, inside the control valve. So against this process pressure, your plug has to move up and down. So it will be, because of process pressure, it is going up, develops a very high, pushing the plug up and up. So against this process pressure, you have to, actuator has to produce more pressure to push the plug down. So that's why you required a higher pressure than this. Only 3 to 15 is not sufficient. This is a signal, okay. So but more than this signal, we need an amplified pneumatic signal to operate the actuator. And also another work of the positioner is, it acts as a feedback device. There is a link here connected with the stem. So if 50% signal is coming from the electro-pneumatic converter, that is something like 7.5 psi. So the condition is that valve has to open 50%. So it takes the feedback position of the valve and it compares with the command, that is a 3 to 15 psi, and ensures that the valve opens 50%. Until that time, it will be applying this pneumatic signal to the diaphragm continuously without any interruption. So when it reaches the 50% of the valve position, so this will be nullified and it will be balanced. So it is also working as a feedback mechanism. So this is required for the process industry, especially high pressure pipelines like gas wells, where there is a huge pressure, process pressure. Against this pressure, the valve has to operate. So we need a positioner. So positioner will have a small gauges showing the supply pressure. So every pneumatic instrument require air supply. So this air supply it receives from the air header or air storage vessel. So there is a small gauge indicating the supply, and input means electro-pneumatic converter output, in fact 3 to 15 psi, so that we can see as a input in the pressure gauge. Then the output, how much pressure it is giving to the diaphragm, that is also shown in a small gauge. So all these things are required in this positioner. So sometimes you will have a combined electro-pneumatic converter as well as positioner in one unit completely, but still the working is the same as I explained to you. So other than that, sometimes we will have a position transmitter. Position transmitter means you are giving a command to operate the valve 50%. So you don't know exactly it is opening 50% or not in the field. Sometimes due to process conditions or problem in the pipeline, valve may not open fully to the required command 50%. So you need actual feedback of the position of the valve. So that position is given by position transmitter, that is 0 to 100% position transmitter. So it gives as an analog input 4 to 20 milliamps to the controller, to the system, where it will be shown as a actual valve position. So this is also very important instrument. It is connected to the stem to get the actual feedback of the valve 0 to 100%. So all these things are required in any control valve actuator. In fact, same thing is applicable here also, that I have not shown here. Only thing is it is a reverse acting type. All other operation is same. Thank you.